Hello there, Voltage Modular people, PoohBear here, and welcome to my channel. And today's video, well, this is probably an intro to an intro, to be perfectly honest. It's just going to be a chat, a high-level chat about my modules. I've had a few people come to me, and they've sort of asked, not so much even technical questions, they're just sort of curious to why maybe I built certain things or why I'm doing things. And so this is really what this video is going to be about, and obviously it's going to be covering all the modules in the PoohBear bundle, and even including a little new one over there. Some of the modules without a doubt have been a spin-off from when I was building something. Some might be a stepping stone for me to build something else, and yeah, so I'm just going to go over a quick chat about that in general. Before I actually start, I thought I'd give you just a little bit of background about myself, because it could be a little bit confusing if you go and look at my Facebook page, and basically I'm down as a dog hydrotherapist and a dog trainer because I rehab dogs. Prior to being a dog hydrotherapist and that, I was actually in the IT industry. I think my first computer I probably touched on, I was quite young at that time, which was been 12 years old, which is quite old, but it was at the end of the 70s. So computers, they just weren't around really at the end of the day. My first computer I ever bought was the Commodore 64 back in, was it 82, 83? It's going back quite far. I remember there wasn't much available for it because I did get it when it virtually came into the country. There wasn't even a proper, you had your basic. I remember writing in machine language, and it was all written in hexadecimal. There wasn't even an assembly language around for it. But the Commodore actually, because it had so many limitations and you had to really write quite optimized code on that device, it set me up for programming other languages in the future, and it always made me think about optimization, and that's something I think about heavily. I've written in quite a lot of different languages. I couldn't tell you how many exactly I've written in, but Voltage Modular is actually written in Java. I hadn't ever touched Java, so this was the first time I was looking at Java. But as I said, I do have a very, very heavy background in programming. I spent 10 years working at Microsoft. I've worked for people like HP. I've worked for people like Compaq, when Compaq were Compaq, because HP did take over Compaq, I believe. Yeah, I'm sure they did. I was also very lucky that I actually worked in the first digital telecoms company in the UK, Cable and Wireless and US West, and Mercury Personal Communication 1-to-1, I believe that's what they launched as. And I think today it's EE. I get confused because telecom companies take over telecoms companies all the time in the background. There's a lot going on. So that was quite an exciting time. But as I say, throughout all my career, I've done a lot of programming. So here we have Voltage Modular. Let's talk about Voltage Modular because that's what we're here for. The first module I wrote actually isn't displayed here. When I pick up a new language, yes, I do that simple hello world to say, yes, is the software installed? Yeah, tick. And then the first program I've written in virtually every single language I've picked up is a simple guess a number game. And I even done the same in Voltage Modular. I've actually got this module which I've obviously never released. It started off very, very basic with an edit text label and another text label, and it's now using obviously controls as well just to make it a bit more advanced. But believe it or not, a simple guess a number is a great stepping stone into a language, because you've got to have an input, you have an output, you have some conditioning, so you've got some if functions, what's going on. And then you can obviously build it up even more, like put a high score in, because then you want to learn about how can I save my data and retrieve my data. So it's a fantastic, simple little program, which is a great stepping stone, and it's actually done me really, 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 really well over all the years, I've been programming. And it wasn't, no different for Voltage Modular. But First Contact was the first device I wrote within Voltage Modular. You could say I picked on this twofold. VM 2500 just come out, so that was the ARC 2500, which appeared in Close Encounters of the Third Kind. And the second reason is it's non-destructive. If I program this and I got the lights wrong and this light was lighting up here instead of this note, well, big deal. I haven't broken anything of anyone's out there. But for me personally, it gave me the great insight into how the CV was actually working with inside Voltage Modular. Obviously, we've got Poly CV as well, so it gave me an insight to that. So this was just a great little program as a great stepping stone into Voltage Modular. Now, a lot of my devices, I actually write multiple times. I tend to write a prototype, then I push it to one side and then I rewrite it. And I try not to look at the code or even use any of that code. Again, I try and write them from scratch. Gator itself was written 4 times from scratch. And it's probably, out of all the devices I've written, is the most complex device I've done. First Contact started off life with some simple LEDs, and then eventually, obviously it's grown into what you can see now. But this is a very, very, very lightweight module. It may look like there's a lot going on because of all the flashing lights. Well, there's 0 flashing lights on this device. You might be saying, hey, I'm going mad, I can see them. But no, they're not. What I did was I actually drew 2 images of 2 different kind of gradient images. I've overlaid them. I've got one which I'm changing the transparency of, so you can get sort of slightly different shades of color going on. And just like an advent calendar where you can open up a door and you get a picture below, these are just like loads of little doors you can open up and you're seeing the picture below. So it's just one picture below this, nothing flashing, and I'm just turning these squares on and off at the very top. That's all I'm doing. So it's something very, very simple. I like basic stuff. And you can get quite a good result out of them as well. Storing forward would be my first sort of real pucker kind of device I wrote. I love arpeggiators because with an arpeggiator, it doesn't matter if you're playing 1 note, 3 notes, or 8 notes. You just play them and they spit data back at you. Problem I have with a lot of step sequences, you've got to go in and say how many steps am I going to be using, and that was really the goal of storing forward. Was I can just play, say, 3 notes, it's going to keep spitting 3 notes back at me. I could play 8 notes, it's going to spit 8 notes back at me, so on and so forth. So it's something for quickness more than anything else, because obviously quickness can be very creative. I find, if you're having to stop start all the time with things, it can break the creative flow. And that's really why I built Storing Forward. And by the way, when I look at devices like Storing Forward, so i.e. step sequencers, I don't look at them and call them step sequencers. In my head, they're voltage steppers. So if you get in your head that this is a voltage stepper and all the other sort of step sequencers you get out there as a voltage stepper, because you can use this, obviously port here can control any parameter within Voltage Modular, and in my case I can take this parameter out and push it through one of these and actually go back into Reason. I haven't really quite said, I am from the Reason world. I think most people probably know that because I have mentioned it a number of times in my videos. It's semi-important because when I have written a few things, there's a specific module here, I go back and talk to Reason, and then I might manipulate something in Reason and then bring it back into Voltage Modular. So Reason does have quite an effect on me of some maybes why I built some of these modules as well. So there wasn't anything like this in Reason. There's nothing like this in Voltage Modular. Yes, there's loads of stuff very, very similar, but it just wasn't what I wanted for that speed, and that gave me exactly what I wanted to easily do. Now, I did have a few edit controls on this, but I removed the edit controls because I found back in the 80s, I did start to go into the digital synths. Yeah, so I was like everyone else, moving from analog into digital synths, thinking that there's going to be the best thing. And we had all these little tiny LCD displays on them, and I call it menu diving, and it's one of the things I hated passionately about the new digital synths which came out. Is you had everything which is menu dive, which was great really for because I've got some early synths where they've got 8 tracks on them, which are brilliant. I've written actually quite a few songs on they referred them as workstations back then, because they all had 8 tracks or 16 tracks, and and you could build them up actually on that one keyboard. But it was menu diving, and it's something I absolutely hate with a passion. And I felt with these sort of controls, I was getting into that that area which it was just too tedious, and I thought, no, I'm going to remove them. I'm just going to have a simple clear button, so if I do a mistake, just clear it and start again. It's 100 times easier. But one of the things I wanted about storing forward was I wanted to be able to say have a rest. So there's no way of doing a rest within storing forward, and that's how Gator actually came about. So if I said I had my 8 notes whizzing around in here, I've got a Gator with 8 steps, and obviously if I turn any of these steps off, that's equivalent of doing a rest. So that's why Gator was born, to give rest for my storing forward. Now, one of the things about a number of devices like this, they're fixed. They're either 8, 16, 32 and 64. Now you might look at this and say, well, actually you've fixed this well, so you've only got 8. It was designed so it could be expanded to whatever size you wanted to. I also wanted to make sure that when I built something like this, that I could limit the amount of wiring that was needed. So if I was to wire up, and you do have to wire them up at 100 of them if you want it to go in turn. So if I put 100 in, I have to wire up this photo, this link down here. But I don't have to take, say, the input and put the input in all of them. I don't have to drive it with the same trigger. I can take that information from this Gator and it drives all the rest of them. And it's the same with the reset. So I just wire up this one device. I can get away with having an input, because one thing I learned was obviously my gate data was going to a trigger and in, and I was using that a lot. Hence I put this link in there, so I don't have to wire up the trigger. I can just put something in, put the link on, and it's gonna work. And so I can get away with 1 wire, 2 wire, and then obviously I just need to wire up my links, and I could have 100 of these, and it would work. Gator's also very flexible, because halfway through you could change the speed of it, so you could have half going at normal speed, half going double speed, slow speed, whatever speed you want basically, because you've got control of the trigger going into it. As I said, with installing forward, I've got a little reason button, because I was going back to reason, and that's really where this spin-off came. So I decided, well, why am I limiting this one device talking back to reason? Hey, let's build it so I can use all the other kind of devices within Voltage Modular and pump that out to reason. I will admit, most of the time I just use the bottom half. I go out to reason. It's very rarely I come in from reason using the audio, because in reason itself we can come in using the top side, so it makes more sense to use usually the MIDI side or the poly side, rather than having to come back in via the audio side. A min-max one I've done because I use it a lot in reason. This is a device I do use a lot in reason, because I end up building a lot of feedback loops. But funny enough, in Voltage Modular I haven't actually built any feedback loops. I say reason has quite a lot of limitations, and that's probably why. One of the things I do use, obviously min-max for, as I said, probably in my technical manual, is I use it to find the extremities, so the maximum and the minimum when I'm testing something, and then once I'm happy I can just rip these out and throw them away. Speed tester actually shouldn't be here, should be down there, because I've never actually released this. Obviously, whilst I was going through testing a number of things, if you've got several devices where you've got an input to an output, every time you're going from one to the other, you're actually adding a sample delay onto that. And really, this is me testing how much delay have I got going on. Gator is actually a special device, because the way I've got this set up is, if I've got, say, 2, I'm going to have a sample delay of 2. But if I've got 100 and I put an input here, I've got a sample delay of 2. It has broken the rules, because I've got a little bit of a PoohBear network going on, which sort of skips a lot of stuff going on in the background. So it's so you do get a lot of kind of sample delays going on, and obviously once I worked out I was getting these sample delays, again that's where Trigate Trigate came in, because it's got its delays, so it can fire the things off at different times. That's a lazy man's transpose. That's the way I like to think of it. I do like to do things with a kind of set and forget. It allows me, without having to transpose my outside keyboard, or a classic thing I love doing is I love taking sequencers to drive sequences, to even drive sequences. So you could take an 8 pattern here, or an 8-step sort of little sequence. I could put a little 4 sequence, say, down here, so that's 4 times 8. So I've now got 32 notes, which I'm now scrolling around. There's going to be sort of a semi-duplication, because obviously we're just transposing. And that's really what Transa does. It allows me to take that output without having to transpose it down theoretically transpose it, should I say, whereas I can just push it into here, which is doing the transposing for me, and then pumping it out to transpose the final result. And then that means I can take this output to go off somewhere else. And usually what I do when I have one storing forward drive and another storing forward is the first one is I tend to use, say, maybe as a baseline, and then I would take that baseline, will make, well, the second storing forward will follow that baseline, and that's the way I tend to do it. High, low port. Funny enough, I've tried to set this up so it is like in order that I wrote stuff, roughly. And you may see that I've got my high-low port, but you probably realise I only released these sort of 3 or 4 weeks ago, so I actually released them probably right at the other end of the PoohBear goodie bag bundle. I wrote them and I didn't release them because I didn't have a good way of demonstrating how to use them. These are devices don't quite exist in Reason. The high port does exist in a way in Reason. The low port doesn't at all. And only literally once, maybe even twice a year, more often once a year, I need one of these kind of devices. So it's not like it's a heavily used device. And as I said, to get a low sort of equivalent in Reason, we have to take the signals, we have to invert the signals, we push them in, then we invert them back, and we do some other things, and it just becomes a little bit of a mess. So that's why I kind of wrote these devices, but I didn't release them because I didn't have a good way of demonstrating them until I actually done my in-C project, where they obviously came to light and they worked perfectly well because they're great at containing, well, they're great for all kinds of things. I use it for kind of ranges, so I can track ranges between many different systems to make sure that they start floating out of range. But they are useful for if you actually had multiple controllers coming in. That's where they're also quite useful. Voltage module obviously is a little bit different in Reason, yeah, because we have multiple controllers coming in. Yeah, we can say, well, this is the highest one, we're going to take that as the value, or this is the lowest one, we're going to take that as the value, no matter what else is going on. So that's where they come in quite handy within sort of Reason more than within Voltage Modular. A big thing I use in Reason is a switch. It's called an AB switch, and it literally is at 2 ins to a 1 out, and that's all it is. But I've configured it in such a way that I'd stack them on top of each other. I'd have LFOs coming in where I'm scaling and doing offsets and doing all other sort of funky stuff to randomly switch between them. They appear heavily in all my sort of generative projects and all the rest of it. And so it was, to me, it just made a natural thing to say, well, this switch, I'm doing all this kind of funny things with, can I actually build a switch to do this? And this is really all this is. And if I actually cover up this little bit here and just leave the flip and the flop in the middle, that flip and the flop is literally a on and off sort of switch. Didn't want to call it on and off because obviously it could be on and on, or even off and off. It doesn't make sense to have it off and off, to be perfectly honest, but it could be on and on. So I decided to call it a flip and a flop. And obviously these sort of knobs here, they're controlling the wiring. What are we doing with the wiring in between the two states? So yeah, so I got myself my little equivalent of my random LFO built in. We can obviously override it in this one, and this one was a nice little counter because counters, as you know, these devices appeared in many of my videos. I use them heavily. There's, that's the good thing about my goodie bag bundle is I've written it for myself as well as all you people, and I do utilize it a lot. These appear a hell of a lot in my videos and in all my projects as well, to be honest with you. In range sort of appeared because I was doing a lot of stuff with my first contact, and I found if I actually set octave ranges, I could set things up and I could have many devices running and they could have their own lane within first contact, just to give me an idea of things which were going on. But it's also, again, a set it and forget it device where I can sort of set a range. They're great in generative sort of projects where you've got a lot of randomization going on and you don't have to then worry too much about scaling things down and offsetting them to get the that CV signal maybe within the right pitch or something, you know, in range does a real grand job of just dragging that signal down into the right range. Obviously, I've got myself a couple of notes, and I got myself some spacers, and I purely wrote them because obviously I was doing some presets, and obviously I wanted to write a few notes for it, and I just wanted the same colors. And these spacers are all the same thing. Just in case you didn't know, you can just double click on these and you will actually change things. Am I actually clicking on the right screen? No, I'm not. Let's double click on these on the right screen. I run multiple screens, and you can obviously change things around. And again, the spinning fan is very lightweight. It's just a few little pictures just flicking in and out. Yeah, this is all stuff I learned from my early days, especially with that Commodore. Now, Polysplitter is purely a stepping stone for building Jazzy Jukebox, and Jazzy Jukebox really came about because I think I was coming to kind of an end with my PoohBear bundle. I was thinking, well, I've done what I needed to do. But the one project I hadn't done in Voltage Modular up to this point was an NC project, which I really, really, really wanted to do. I love NC, and I was looking at all the modules within VM, and there was nothing which would allow me to do what I needed to do. Because NC projects are quite hefty projects because the amount of data you're having to shift around. So the whole point, you know, NC, it's got its 53 phrases, so I needed a way that I could switch between my 53 phrases, and so Jazzy Jukebox come around. Yes, this does support 128 phrases or 128 MIDI files at the same time, because that, you know, I chose that number because you can then select it from a MIDI keyboard, so it ties into a MIDI keyboard. Again, we got this 1 volt to 128. This is a Reason sort of range. You know, we're used to using from 0 to 1 volt. We have all our MIDI data contained within that 1 volt, and that's what we use. And I've got some other devices which spit that range out, so we can just sort of tie them in together quite nicely. So that is how Jazzy Jukebox came about, and from Jazzy Jukebox I had a few things spat out to one side. I noticed that when I was doing a note off, or when I switched between MIDI files, I was sending out a MIDI signal called all note off, and I found some devices which weren't turning all their notes off. They was ignoring that all note off message, and so I decided to say, okay, I built this device which should really call MIDI notes off, I suppose, because it will receive an all note off message and actually convert it and say, no, I'm going to send a note off to all notes. Unfortunately, this is how it has to work, which is 128 notes. There's 16 MIDI channels, so that's 2048 messages it sort of sends out to say, hey, turn everything off. And this was just a simple little checker because I was having some funnies where I was loading files up, and then externally from Voltage Modular, things weren't happening the way I was expecting them to happen. So they'd work one way in Voltage Modular, and they'd work a different way outside of Voltage Modular with different hardware and different software. And I sort of tracked it down to there's, you could say in the MIDI world, there's two things. There's something which is MIDI compliant, and there's something which is MIDI compatible. So there's a lot of MIDI compatible stuff out there, which means it's not going to follow the full MIDI spec. So they're not compliant, they're just kind of compatible. And so what I found was there's a number of devices I've got which are ignoring note on 0 velocity. It just treats them, well, there's just still a note on, it's waiting for a note off to turn, say, that voice off. Now, obviously, in the MIDI world, in proper specifications, a note on 0 volt should turn stuff off. It doesn't quite do that. So what I do with Jazzy Jukebox is, if I load up a file and I come across a 0 volt note on message, I automatically turn it to a note off, and it works with all my external stuff and all other sort of software really happily. And that's all this was doing. This was just sort of tracking these kind of messages going on to give me an idea of maybe why something wasn't quite working the way it should have been working. So it's, you know, you may find a usage for it. It's just something I built and I thought I'd just throw it out there. But say that as a spin-off from Jazzy Jukebox. And finally, on the very, very end here, we got ourselves, hey, this is called the Black Box Area C. So let me just talk about that. So you may recognize this as my NC project. This is actually a 12 voice one using tiny voices. What I'm going to do is let's remove the tiny voices, let's remove all the mixer stuff and everything else, and let's just bring it down to its raw stuff, so it's just purely like the CV, which is driving the NC stuff. I've actually also added 4 voices, so this is 16 voices. So we need all of this to make up 16 voices. I'm going to take all of this and I'm going to absolutely squeeze it down into this one little box. So now this one little box was doing everything what you could see. You have a little bit of control over the min and the max. That's actually to do with the time range, so you could actually make this project last 7 hours if you wish to. Obviously the great thing about this, as you can see, 16 voices playing really happily. I've got loads and loads of spare CPU power as well. But the more, the key thing is now is, we can put this in and you can just spend your time doing the sound design. Some people prefer the sound design, some people prefer actually doing the CV wiring. If you're into the sound design, this is your perfect opportunity. And the black box Area C doesn't do anything more, but it just does an NC. You've got a start, stop, reset, and off you go. Simple as that. Hopefully you found this video of some use. Please let me know if you need to know any other kind of information. So I'm more than happy to do videos about things and to talk about my modules or to help out in general. It's the sort of, as I say, that's what my IT career's been about. It's actually been really third line support most of the time. But yeah, so thank you for watching and bye for now.